You asked, what is making Europe's wildfires spread so fast? And 2 articles offer a clear 1-2 punch of an answer. Writing in late June, as summer began baking the continent, Rachel Clun explains the mechanics of a heat dome, a trapped layer of high pressure turning forests into tinder. What happens after the spark is even stranger. In a piece published just yesterday, Jason Sharples, Andrew Dowdy, Luke Burgess, and Todd Lane detail how large blazes generate their own violent weather. They form massive clouds that suck in air and spit out erratic winds. Listening to both reveals how a stationary heat trap primes the ground, only for the fires themselves to whip the flames forward. When temperatures spiked across Europe in late June, Rachel Clun wrote this piece to explain the physical mechanics of a heat dome. Notice the everyday image she uses to describe the trapped high pressure sitting over the continent, a lid on a saucepan. As the hot air expands and bulges, it compresses warmth into a smaller region, baking the ground below and making it even easier for the heat to keep rising.
What is a heat dome? How Europe's scorching temperatures are driving the UK heatwave. The UK is expecting its second heatwave of the year as continental Europe braces for 40°C heat. The Met Office has issued an amber weather warning for extreme heat across parts of the UK ahead of a significant heatwave expected this week. The warning, covering the southwest, the southeast, the east of England, and sections of South Wales, will be active from 1 a.m. on Monday until the end of Tuesday. Forecasters predict the developing hot spell could lead to widespread impacts on people and infrastructure. Meteorologist Max Dakin stated that temperatures could potentially reach the mid-30s next week, following what is anticipated to be a very warm weekend for many. The unseasonably hot weather is being driven by a significant area of trapped high pressure building in Europe, known as a heat dome, which is triggering scorching temperatures across the continent. Here we explore what causes a heat dome and how a heat wave is defined. What is a heat dome? A heat dome is created when a high-pressure area stays over the same area for days, or potentially weeks, trapping very warm air underneath it, like a lid on a saucepan. Because hot air expands, it creates a dome that bulges out. This weather phenomenon causes temperatures to become hotter and hotter, building through the day and rise above what is considered normal, since warm air becomes compressed over a smaller region. The ground warms as well, and moisture evaporates, the RMS says, making it easier for temperatures to continue to rise. These weather systems and their prolonged heat also increase the risk of wildfire and heat-related health problems, the Royal Meteorological Society said.
Often these pressure systems move east to west, the RMS explains. Sometimes they can be blocked when the jet stream of strong winds high in the atmosphere weakens. Large parts of central and northwestern Europe will be covered by these conditions the coming days, with temperatures expected to reach around 10 degrees Celsius above mid-June averages, according to the Met Office. Spain, France and Italy will see temperatures rise well into the 30 Celsius, and some areas could exceed 40 Celsius. The UK will see a more varied and complex pattern as the warm air from Europe attempts to move northwards and contrasts with low pressure in the northwest. This means northern and western parts of the UK will likely see repeated spells of rain due to the cooler weather front, while southern and eastern areas will see temperatures rise steadily. What is the definition of a heatwave? A heatwave is simply a prolonged period of abnormally high temperatures. What is considered an abnormally high temperature varies from place to place. Several countries issued heatwave alerts ahead of the weekend, including Spain, which experienced temperatures of up to 42 Celsius in parts. In France, the Meteorological Office has issued an orange heatwave alert for nearly the entire country, with temperatures expected to reach scorching levels. In Mediterranean cities and towns, the French Meteorological Office expects temperatures of up to 40 Celsius, while only regions near the English Channel and the border with Belgium will experience temperatures below 34 degrees. Paris is forecast to reach 37 degrees on Monday and Tuesday. Lisbon is forecast to reach 41 degrees on Monday, while temperatures in Rome are expected to peak at 37 degrees on Wednesday and Thursday. In the UK, temperatures could reach 35 degrees Celsius in the southeast on Tuesday, Met Office forecaster Matthew Lenhart said. The June temperature record of 35.6 degrees Celsius was last reached nearly 50 years ago, in 1976. Join our commenting forum. Join thought-provoking conversations, follow other independent readers, and see their replies. Comments.
Rachel Clun leaves you looking up at the sky, watching a trapped lid of hot air bake the ground below. Her explanation of a heat dome sets up a clear chain of events. The atmosphere stagnates, drying out the earth, until entire forests sit waiting for a spark. It paints a straightforward picture, where the weather dictates exactly what happens in the dirt. But turning to Jason Sharples, Andrew Dowdy, Luke Burgess, and Todd Lane, that one-way street suddenly flips. They look at what happens after those forests actually catch fire. What jumps out is how quickly a blaze stops being a mere result of the heat dome and starts acting like a weather system of its own. The authors describe fires releasing so much energy that they punch massive updrafts into the sky, eventually forming towering storm clouds packed with ice and supercooled water. Read alongside Clun, this second piece changes how you look at the sky. The atmosphere isn't just a heavy lid pressing down on passive trees. Once the flames get hot enough, the ground pushes back, generating its own wind and lightning to keep the destruction moving.
What are pyrocumulonimbus clouds, the weather system that can worsen wildfires? Pyrocumulus clouds can dramatically alter the spread and intensity of wildfires. Bookmark. Comments. Go to comments. This article was originally published by The Conversation in January 2026 and is being republished by The Independent as wildfires rage across France and Spain. Bushfires are strongly driven by weather. Hot, dry and windy conditions can combine to create the perfect environment for flames to spread across the landscape. But sometimes the relationship flips. Fires can generate their own weather systems, which can then dramatically alter the spread and intensity of the blaze. One of the most striking examples of this phenomenon is the formation of pyrocumulonimbus clouds, towering storm clouds born from fire. How can a fire make winds and clouds? Large bushfires release enormous amounts of energy, sometimes comparable to that emitted from a nuclear bomb. This heats the air in the vicinity of the fire, causing it to rise rapidly in a powerful, buoyant, fire-driven updraft. Surrounding air rushes in at ground level to replace the rising hot air, feeding the fire with oxygen like a bellows, and sometimes accelerating its spread. In extreme cases, the fire and its induced winds can become a self-sustaining system, feeding and growing from the weather it creates. If the plume rises high enough, it can cool to a temperature where the water vapour in the plume will begin to condense into clouds. This is essentially the same process that leads to the formation of ordinary cumulus clouds, except it occurs within a fire's plume and is called pyrocumulus. Fire-generated thunderstorms. If the fire is large and intense enough, the plume can keep rising. As the cloud rises above altitudes of around 3 to 5 kilometres, temperatures can drop well below freezing. Water droplets freeze into ice crystals, releasing another burst of latent heat that further energises the rising plume. The rapidly rising plume now contains ice and supercooled water, a mixture that is key to thunderstorm-like processes. It is through this process that a fire-generated thunderstorm is born, a pyrocumulonimbus cloud. Pyrocumulonimbus clouds can reach altitudes of 10 to 15 kilometres, penetrating the stratosphere. Inside them, strong vertical motions generate turbulence, with ice and water droplets colliding and causing the separation of electrical charges. This can result in lightning, often striking far from the original fire front, and in some cases igniting new fires. These clouds can rise so high that they leave a clear signature visible by satellite, including a long shadow cast over the rest of the cloud and smoke. The first pyrocumulonimbus for this summer may have happened yesterday near the border of NSW and Victoria. Lightning was detected nearby, but this was among lightning occurring in many places across the southeast states, so it may have just been pyrocumulus clouds, which can still present a significant threat. For example, the deadly 2019 Jingellic fire, which produced tornadic winds, developed a towering pyrocumulus, but not a pyrocumulonimbus. The strong updrafts created by pyrocumulonimbus can cause gusty conditions, accelerating fire spread and making it less predictable. The storm can produce a strong updraft, bringing fresh air in underneath to the fire, while flinging burning embers over 40 kilometres, potentially creating new fires.
At the same time, strong downdrafts created by the storm can flatten trees and create dangerous conditions for firefighters. When does this happen? Not every bushfire spawns its own weather. Pyrocumulonimbus formation requires a delicate balance between the size and intensity of the fire and the stability of the atmosphere. Firstly, the fire must be large and intense enough to release massive amounts of heat. Secondly, the surrounding atmosphere needs to be suitably conducive to vertical motion. Both of these together allow for the plume to rise. Third, moisture in the mid-levels of the atmosphere can enhance the chances of pyrocumulonimbus formation. Moist mid-level air can get caught up in the rising plume and then add to latent heat release when it condenses and freezes, which keeps the plume rising. The future of fire and thunder. Fire-generated thunderstorms were practically unheard of a few decades ago, but they appear to be becoming more common. One notable example is the unprecedented number that occurred during the Black Summer of 2019-2020. Other outbreaks include around Melbourne in the Black Saturday fires of 2009 and the Canberra fires in 2003. In all of those cases, the thunderstorms were so intense they injected smoke into stratosphere, where it circled the Earth and affected global climate patterns. Other examples of extreme weather they can cause include fire-generated tornadoes, as well as black hail in the Canberra fires. Human-caused climate change has already caused more dangerous weather conditions for bushfires for many regions of Australia, including more dangerous conditions for fire-generated thunderstorms. About the authors. Jason Sharples is a professor of bushfire dynamics, School of Science, UNSW Canberra, UNSW. Andrew Dowdy is a principal research scientist in extreme weather at the University of Melbourne. Luke Burgess is a PhD candidate in weather and fire extremes at the University of Melbourne. Todd Lane is a professor at the School of Geography, Earth and Atmospheric Sciences, ARC Centre of Excellence for the Weather of the 21st Century, the University of Melbourne. This article is republished from The Conversation under a Creative Commons licence. Read the original article. Observations show more dangerous conditions are now occurring during summer and also with an earlier start to the fire season, particularly in parts of southern and eastern Australia. These trends are very likely to increase into the future, with climate models showing more dangerous weather conditions for bushfires and fire-generated thunderstorms due to increasing greenhouse gas emissions. Why understanding this matters? Understanding how bushfires can create their own weather is crucial for forecasting and emergency response. Traditional fire behaviour models often assume that weather drives fire, but when fires start driving weather, those models can fail. Incorporating prediction of fire-generated clouds into fire management systems helps authorities anticipate sudden changes in fire intensity and spread. Targeted research incorporating satellite monitoring and advanced atmospheric modelling is now being used to better understand and detect conditions favourable for pyrocumulonimbus formation. This knowledge allows for better warnings, resource allocation, and strategies to protect lives and property. Bushfires are no longer just a local hazard. They can become atmospheric engines with global reach.
What lingers is the image of a continent sitting quietly under a lid of hot, still air, waiting. The stagnant heat bakes the forests until a single spark hits dry timber, shattering the silence. The fire begins to swallow the sky, building towering storm clouds that breathe violent wind back into the flames. The weather primes the trap, and the fire springs it. When a blaze grows large enough to hijack the atmosphere and spit out its own unpredictable storms, how do the people in its path know which way to run?